Hi everyone, so I'm going to go over a simple quick lesson. So it's using sum and difference. Sum and difference identities. And the ones we went through class already are the cosine of, we'll say a plus b is cosine cosine. Minus sine sine. For sine, it's going to be sine cosine. And we're going to say plus cosine sine. Now, the way for me to remember these a little bit easier for me is if I say cosine, I directly say cosine. So I say cosine is cosine cosine. And when I say sine directly. So sine cosine. So cosine is cosine cosine, and sine is sine cosine. And the second part just follows in kind of semi-reverse, except with cosine it's cosine cosine sine sine, and with sine it's sine cosine cosine sine, reversing that. Okay. So an example of this would be the cosine of 165 degrees. So I don't know what cosine of 165 degrees is just off the top of my head. It's not one of the special triangles. But the trick here is to realize that this is actually made up of two special triangles that we already know. It's cosine of 120 plus 45. Now here's a hint. If you see a 5 and you're not given a calculator, it's probably going to be a something plus 45. It's something plus 45 or something minus 45, right? It's one or the other. Both of them will get to us to the same answer. In this case, let's use the plus version. So now that I've decided to use my sum identity, let's write that out. To use the top one up here, it's going to be cosine cosine sine sine. So cosine 120 cosine 45 minus sine 120 and sine 45. Now, we know what the triangles 120 and 45 are. These are our special triangles. So for me, I like drawing them out so I can visually see them. I'm going to draw two angles. Angle 120, going up here, this is 120, and yeah, that's 120. But for us, the special right triangle would be a 30, 60, 90. This will be leaving us 60 in our corner there. And this is going to be a 30, 60, 90. So we have a 1, 2, square root of 3 triangle. Remember, if we're going left, that the x value is going to be negative. On our 45-degree triangle, that's in quadrant 1. 1, 1, square root of 2. And just for our sake, we're going to say 1 over square root of 2 will equal to square root of 2 over 2, right? That's us rationalizing the denominator. Okay, so now that we have these two triangles drawn, let's go ahead and fill out what is the cosine of 120. What is the cosine of 45? What is the sine of 120 and what is the sine of 45? So the cosine of 120, hey look, I drew the triangle here already. So the cosine is going to be adjacent over hypotenuse. So it's going to be adjacent, negative 1 over hypotenuse of 2. The cosine of 45, looking on the right, it's going to be adjacent is 1, hypotenuse square root of 2. We're going to rewrite that as a square root of 2 over 2. This is going to save us a lot of time later. On the right side, on the next part about sine 120, sine 120 is going to be opposite over hypotenuse, square root of 3 over 2. And our sine again is 1 over square root of 2, rewriting that as square root of 2 over 2 to save us time. All right, we're almost done now. Looking here, on the bottom, 2 times 2, 2 times 2, we have a common denominator of 4. So it's going to be negative square root of 2 minus square root of 6 all over 4. Now, the difference versions, just to lay those out for us. So if I do cosine of A minus B, this would be cosine cosine again, cosine A, cosine of B, and then we're going to end up with sine of A, sine of B. And since the sign changes here, we're just going to change that to a plus sign. It's looking very similar to the Pythagorean theorem, but not, because they are different angles. is not cosine squared. And then the sine of A minus B. When we said sine, we said we're going to say not sine sine, but sine cosine. Cosine of B, whoops. And then followed by cosine sine. And we start off with a plus, and this will give us a negative 1. Okay? We just have two more extra identities for tangent. So tangent of A plus B. This will be tan of A plus tan of B all over 1 minus tan A tan B. And the difference would be tangent of A minus B is equal to tangent of A minus tangent of B over the flip sign 1 plus this time tan A tan B. Okay. Now we'll see another type of question in the homework, and it's going to have us go backwards. So let's come up with an example of that. Now, looking at this problem, I do not know what a 40-degree triangle looks like. That's not a special triangle or an 80-degree triangle. But if you go back up here and we look at our sum and difference, which one do you think this would match? Cosine, cosine, minus sine, sine. Cosine, cosine, minus sine, sine. Well, cosine, cosine, we automatically know it's going to be a cosine. So will it be this guy or this guy? Well, the sign in the middle helps us figure that out. So if it's cosine, cosine, minus sine, sine, that's going to be our plus identity, our sum identity. So our sum identity right here, see how there's a minus? So let's go ahead and rewrite this and consolidate it. This could be rewritten as the cosine of 40 plus 80. Well, 40 plus 80 combines up to become the cosine of 120. And great, the cosine of 120 is a triangle that we know. That's a special right triangle for us. Here's 120. We can draw our triangle in quadrant 2. That's going to be 60 because it's left over from 120 to 180. 1, 2, square root of 3. Because 1 always goes next to the 60. This is in quadrant 2, so the x value is going to be negative. Now, what is the cosine of 120? Looking here, that's going to be negative 1 over 2. And again, working back with a triangle that we know. So the point here is we don't know our triangles for 40 and 80, but when I do combine them, we end up with 120, which is a triangle that we can work with.